Hi there, ladies. We are reviewing for our final. We're going to start with chapter 4. So your assignment for tonight is page 1013, and we're going to work through these following problems. So problems 1, 5, and 7 are asking us to graph. Problem number 1 is given to us in standard form. So when we graph in standard form, our equation for our axis of symmetry is x equals negative b over 2a. Well, in this problem, a is 3, b is non-existent, it is 0, and c is 5. So that means that our axis of symmetry is at x equals 0. So we draw in that vertical dotted line that we're going to use to reflect our points, and then we'll move on from there. So next we need to find our vertex. Our vertex is going to have the same x-coordinate as our axis of symmetry. And then to find out the y-coordinate, we are going to plug it in. So we've got y equals 3 times 0 squared plus 5. Well, 0 squared is 0. 3 times 0 is 0. 0 plus 5 is 5. Now I'm going to hold off to plot that point for just a couple seconds until we get the rest of our points figured out, because we're going to end up counting by something other than ones. Because our graph has a vertical stretch by a factor of 3, and we know that it's going to open up. So that can help us determine, oh, hey, wait a minute, we should probably wait to plot these points. So we've got our vertex, it's ordered pair 0, 5. Our y-intercept is also going to be a helpful point, and it has the ordered pair 0, comma, c. Well, it's 0, 5, which makes sense because we already figured out what happens at 0. We get 5. Well, since our vertex and y-intercept are the same point, we need at least 5 points altogether, so that means I just have to plug in 2 additional x-coordinates. So let's pick 1 and 2, because why not? We always want to pick 2 points on the same side of the axis of symmetry. Well, our y-intercept was on our axis of symmetry, so you just pick a side. Let's go right, because we've got positive numbers. So we're going to plug in 1, so we have 3 times 1 squared plus 5. 1 squared is 1, times 3 is 3, plus 5 would be 8. Then plugging in 2, we have 3 times 2 squared plus 5. 2 squared is 4. 3 times 4 is 12. Plus 5, we get 17. So there was that y-coordinate I was waiting for. That's way bigger than 10, which tells us we're going to want to scale our y-axis by 2s. Our x-axis is fine being counted by 1s. Now we'll plot all the points we've got so far. So our vertex slash y-intercept is 0, 5. So we go up 5. And then 1, 8. We're moving right 1 up 8, which remember is really just 4 tick marks because we're counting by 2s. And then our other point, we'll graph it in blue. We're going to move right 2 up 17. So that's going to be right here. Our last step of graphing a parabola is always to reflect and connect. So we've got this orange point that is 1 tick mark away on the right. So we move 1 tick mark away on the left and plot the point. Same thing with our blue point we just plotted. It is 2 tick marks away from that axis of symmetry. So we are going to move 2 tick marks away on the left, plot a point, and reflect. Now we connect. Oops. So it's always going to be a U shape. Hopefully it'll go through the points. Good enough. There is our parabola. In number 5, this time it's in a different form. It is in vertex form. So the first thing we pick out is a, h, and k, so different variables. We've got a is 4, h is positive 2. Remember, it's always the opposite sign of what we see. Our k is the plane with positive 1. Our axis of symmetry for this parabola is going to be x equals h, which for us is x equals 2. So we will plot that line. There's our axis of symmetry. Next comes our vertex, and it's the ordered pair HK, so 2, 1. Now again, I'm going to wait to plot these points because we are eventually going to have a point that is way off our graph. So I'll plot it in a second. Next, we'll plot our y-intercept. When it's in vertex form, we have to take the time to plug in x equals 0, but that's fine. So we have 4 times 0 minus 2 squared, so negative 2 squared plus 1. Negative 2 squared would be positive 4. 4 times 4 is 16. Plus 1, our y-intercept is up at 17. So we are going to plot or let our y-axis count by 2's. Our x-axis, we're still counting by 1's because we've got plenty of room there. So our vertex, we can go ahead and plot that point, right 2 up 1, and y-intercept 0, 17 takes you all the way up there. Lastly, we need to pick a point to plug in. Pick a point on the same side of the axis of symmetry as your y-intercept. Notice your y-intercept is on the left of that purple dotted line, so we're going to pick another x-coordinate to the left. Hey, let's pick +1. Why not? And we just plug it in. So 4 times 1 minus 2 would be -1. Squared plus 1. -1 squared is 1. 4 times 1 is 4, plus 1 we get 5. So we're moving right 1 up 5. Remember, we're counting by 2's. And lastly, here comes our reflection. So we reflect across our dotted line, and we connect all of our points with a smooth parabola-shaped curve. Last one is going to be in intercept form. And so the first thing that we are able to recognize is what our x-intercepts are, which is rare. So our x-intercepts, remember, we're always going to have y-coordinates of 0. And we find them by setting these parentheses equal to 0. It's always just going to be the opposite sign. So we have +1, 0 and +5, 0, which are points that I can plot right away. Now, this time to find our axis of symmetry, you want to average out your x-coordinates that were your x-intercepts, or you can just figure out what's halfway in between. So as you try to find the midpoint of our 2 x-intercepts, well, halfway in between is going to be right there at x equals 3. So apparently our axis of symmetry is x equals 3. Oopsies. And then to find our vertex, we need to go ahead and plug in x equals 3 for an x-coordinate. So we've got 3 times 3 minus 1 is 2, and 3 minus 5 is -2. Multiplication, we just work left to right. 3 times 2, we get 6, times -2 is -12. We get to count by 2's again. Moving down 12, 2, 4, 6, 8, 10, 12 takes us right here. Now we just need one more point that we're going to be able to reflect, and that'll be our y-intercept, which means we're going to plug in x equals 0. So we have 3 times 0 minus 1 times 0 minus 5. 3 times -1 is -3, times -5 would be +15, and we go ahead and plot that point. Now, that is the only one that we actually have to reflect, because our 2 x-intercepts, when you reflect them, you get the other x-intercept. So then we just reflect that one point, and we draw in a very steep but smooth parabolic shape. There are our 3 graphs.